Hello students, welcome to my first video lesson on probability, and this is for grade 10 mathematics. Alright, basically I'll be teaching you here based on two important things or two important topic. Okay, I'll be letting you to prove, or I'll be teaching you on how to prove independent and dependent event. So before you actually go into the main topic or the main portion, I want you to come across some of the terms which you have already studied before, but I just want to do a bit of revision on that term. Students, let us see what are probability devices. Alright, in the first place we have coin. We already know that coin has two sides, head and tail. Sometimes we call that as tashitage and korlo. And we also have dice having six different sides. We have cards here. A deck of cards contain 52 cards. We have spinner. It depends upon the types of spinner we are that is given in the questions. Alright, so these are the four different types of probability devices. We are going to calculate the probability based on these four devices only. Okay, now let us look at what are some of the methods to calculate probability. Listing method, outcome chart, and tree diagram. So basically we will be using any of these methods. Alright, from the three methods we can use any one of these. How do we calculate theoretical probability? Let us see. Probability of any event P of E equals to number of favorable outcomes divided by total possible outcomes, which is also called as number of sample space. Types of events. The main topic for the day is events. We are talking about types of events. Independent event. So what is independent event? When the outcome of one event doesn't affect or depend on the outcome of other event, that is called independent event. Example 1, we have event A, rolling a die and getting even number. Event B, tossing a coin and getting tashitage. So let us verify whether they are dependent or independent. The above event A and B are independent. They are independent event as the outcome of one event doesn't affect the outcome of other event. The outcome of event A is not affecting the outcome of event B because the probability devices used are different. That is a coin and a die. In event A, a die is used. In event B, a coin is used. What is dependent event now? Let us see, students. When the outcome of one event affects the outcome of another event, it is called dependent event. We have example 2 here. We just have done example 1. Event A, drawing a king from a deck of cards in first draw and is not replaced. We have event B, drawing a king in the second draw. We already know in a deck of 52 cards there are 4 different suits of king. The events A and B are dependent as the outcome of event A affects the outcome of event B, as the card drawn in event A is not replaced when event B happens. Here if you see in event A and B, event A in the case of event A, a card is drawn and it is not replaced. In a deck of 52 cards, one it is drawn, and when the second event is performed, that card is not replaced, so it means it remains only 51 now. Total number of cards would be. So now let us see. Usually we have sample space of 52 cards. So probability of A is 4 over 52. There are 4 suits of king, and probability in the event B, we see the probability of B is 4 over 51 because the card is not replaced from the first event. Sample space is changed since the card in the first draw is not replaced when second draw is performed. So dear students, we just went through the meaning of independent and dependent events, and we also somehow came to know that through justifications, through reasoning, how can we actually differentiate between dependent and independent event. Now let us see here. When we are not able to determine through reasoning whether the events are dependent or independent, when you're not able to distinguish or determine through reasoning, in such cases we determine it through calculations, which means we have to do by calculating. We cannot differentiate, we cannot distinguish whether that event is dependent or independent through reasoning. Here we have to perform calculation. All right, my dear students, now let us see example 3. We have event A and B. Event A, rolling a die and getting 1 in the first roll. Event B, rolling an even number in the second roll. First step we need to keep in mind is determine the probability of both events happening as separate events. Now we have, since it is a single die rolling, so we have sample space, number of sample space is 6. Event A is getting 1, so number of event A favorable outcome is 1. Event B is getting even numbers, that means out of one die even number would be 2, 4 and 6 we have here. So n of B, number of favorable outcome is 3. Now probability of any event P of E equals to, we already have the formula, you know very well. So P of A is now 1 over 6. We have P of A 1 over 6. P of B we have 3 over 6, which will come as half. Alright, now if you see in the next one, probability of A times probability of B, when you do when you multiply 1 over 6 times 1 over 12, when you multiply, 1 over 2, when you multiply, you are going to get 1 over 12. Alright, my dear student, now let us see in the next slide. Step 2, determine the probability of both events as combined event. Step 1 was finding as a separate event. Now here we have to find as a combined event. Now we have here, we have to find the P of probability of A and B, that is P of getting 1 and getting even numbers. Make the use of outcome chart as sample space. So we have here a bit different than step 1. We have first roll here, we have second roll, so the sample space would be, now this is the sample space. All right, 1 1 1 2. So if you count the number of sample space, n of s would be, total number of sample space would appear as 36 here. All right, now therefore probability of A and B, probability of getting 1 and getting even number. Now let us check it out. We have 3 here. So how it is? Getting 1 means here in the first draw you get 1, in the second draw you get even number, means 1 2. 1 3 we cannot take because 3 is not an even number. 1 4 we can take, 1 is getting 1 and 4 is even number, and 1 6 we can take it. Alright, so likewise we have 1 2 and 3, so we got here 3 over 36, which means 1 over 12. Now let's next. Now compare the probabilities of first and second step. So we have to compare the probability of whatever we have done in the first step and second step. Let us see. P of A times P of B equivalent to P of A and B. So what you got? P of A is 1 over 12, as well as P of B is also 1 over 12. Therefore the events A and B are independent. So they are independent because they are equal. If the probabilities are not if the probabilities are not equal, then the event would be dependent. If the probabilities were not equal, the event would have been dependent. Now let us check in one. Example 4, event A and event B. We have event A says rolling a die and getting 1 in the first roll. Event B says rolling a sum of 5 in 2 rolls. So we need to prove that whether this is dependent or independent event. First we need to write it as a separate event. First roll, second roll, this is the sample space, so we'll make it solve it as a separate event. Only one die is rolled in the first event, only one die is rolled, so therefore the sample space is 6. Now in the second event, so which is why we will be getting 1 over 6, because when you roll a die out of one die, when you roll a die and you will get only one, the probability here getting 1 would be only 1 over 6. Now let us see in the event B. For event B we need to have total number of sample spaces B 36. Alright, so event B says getting a sum of 5 in 2 rolls, so we are going to get a sum of 5 in 2 rolls. So let's check it out. Sum of 5 in the 2 rolls. 1 4, 1 plus 4 is 5, 2 plus 3 is 5, 3 plus 2 is 5, 4 plus 1 is 5. So we got here we have 4. Now let us check it out. Getting a sum of 5 in 2 rolls we have, so number of the formula is already there, we already know the formula, so 4 over 36. So if you see the combined event, what does the combined event says? Rolling a die, getting 1 and sum of 5. In the first draw you have to get 1, and when in the second draw you have to get sum of 5. So 1 4 1 and 4, so which means here you'll get 1 over 36 as a combined event. As a separate event we got 1 over 9 and 1 over 6. So let us check it out. Yes, therefore probability of A times B, the separate as a separate event, probability of A is 1 over 6 times 1 over 9 is not equivalent to 1 over 36. We get 1 over 54. So it is not equivalent, which means the it is a dependent event. The probability is a dependent event. So my dear students, hope I made it very clear in how to distinguish dependent and independent event, and also how to find the dependent and independent event, isn't it? First we need to find as a separate event, and then you have to find as a combined event, and then you have to compare by multiplying it. So these are the questions for practice. Let me read it for you. Question number 1, Sonam randomly chooses an integer from 1 to 50. Event A, the number is a multiple of 3. Event B, the number is a multiple of 5. So here in this case what you need to do is choose the number from 1 to 15. So event A is multiple of 3. So from 1 to 50, what are the multiple of 3? You write it. Event B, from 1 to 50, what are the multiple of 5? You write down. So what is the probability that event A happening? So what is the probability of happening of event A? You find it. What is the probability of happening of event B? You find it. Sorry, and then event A and B both combining, which means here you have to find proof for dependence and independence, dependence or independence proof. Yeah, you need to prove for dependence and independent condition. All right. Question number 2 says, what is the probability of getting a 3 in the first roll and sum of 5 in 2 rolls? Are the events dependent or independent? Explain. So you need to find it out. All right, my dear students. So thank you students for watching this video, and have a good day. If you have any doubts, let me know, please.